Imagine your dream home, the one you've worked so hard to build. Now, imagine watching it develop cracks, start to lean, and slowly sink into the ground just a few years later. It's a homeowner's worst nightmare, but it's a reality for too many. Have you ever seen houses that start sinking after just a few years? It's a heartbreaking problem across Nigeria. But what if I told you that most of these structural failures are completely preventable? In this video, we're going to uncover the hidden reasons why buildings sink, and more importantly, show you how to protect your investment and build a home that stands strong for generations. The warning signs often start small. You might first notice a door that suddenly starts sticking, or a window that's difficult to open and close. You might dismiss it as the house just settling. Then, you spot a crack in the wall. At first, it's a hairline fracture, but over weeks and months, it widens and spreads. You might start to feel an unnerving slope in the floor, or see gaps appearing between the wall and the skirting board. These are not minor cosmetic issues. They are urgent distress signals from your building's foundation, telling you that something is seriously wrong underneath. Ignoring them can lead to catastrophic failure, expensive repairs, and a constant state of worry. Recognizing these signs early is the first step to diagnosing the root cause. So what is the number one culprit? It's the ground itself. Building on weak or unsuitable soil without proper investigation is a recipe for disaster. Many areas, especially in coastal regions like Lagos or riverine environments, have what we call weak soils with low bearing capacity. Think of soils like black cotton soil, peat, or loose sand. Imagine trying to stand on a soft, spongy mattress versus a hard concrete floor. The mattress will compress under your weight. Weak soil acts just like that mattress, compressing and shifting under the immense weight of a building. This leads to what engineers call differential settlement, where one part of the house sinks faster than another, causing the cracks and slopes we just saw. Expansive soils like clay are another major problem. They swell up like a sponge when they get wet and shrink dramatically when they dry out. This constant movement of swelling and shrinking exerts incredible pressure on a foundation, lifting and dropping it year after year, eventually leading to structural failure. Building on weak soil without testing is a major cause of sinking buildings. How do you avoid the soil trap? The answer is simple and non-negotiable. You must conduct a professional soil investigation before you even think about designing the foundation. This isn't an area to cut corners to save money. A proper geotechnical investigation involves several key steps. First, engineers will visit the site to assess the general topography and geology. Then, they use drilling rigs to bore deep into the ground, extracting soil samples from various depths. This allows them to see a clear profile of what's underneath your plot of land. During this process, they perform tests like the Standard Penetration Test, or SPT, which measures the soil's density and strength right there on site. Finally, the collected samples are taken to a laboratory for further analysis to determine their specific characteristics, like their composition, moisture content, and how they will behave under load. This entire process gives your structural engineer the critical data they need to understand the ground's bearing capacity and design a foundation that is perfectly suited for your specific site. Once the soil test results are in, the engineer can choose the right weapon for the job, the foundation. There is no one-size-fits-all solution. Using the wrong foundation type is just as bad as not testing the soil at all. For sites with strong, uniform soil near the surface, a simple and cost-effective strip foundation might be sufficient. This is a continuous strip of concrete that runs under the load-bearing walls. However, if the soil is weaker or has variable conditions, a raft foundation might be recommended. This is essentially a large, reinforced concrete slab that covers the entire footprint of the building, spreading the load over a much wider area, much like a snowshoe helps you walk on soft snow. For very weak, swampy, or waterlogged soils, like those in many parts of Lekki or Port Harcourt, you'll likely need pile foundations. These are long, slender columns of concrete or steel that are driven or drilled deep into the ground, bypassing the weak upper layers of soil to transfer the building's weight to a stronger, more stable layer of rock or dense sand far below. Using the wrong foundation type leads to settlement. Even with the perfect foundation, your building is still vulnerable to another powerful enemy, water. Uncontrolled water around a building's base can be devastating. It can saturate the soil, drastically reducing its bearing capacity and turning stable ground into a soft mush. This is why proper drainage is not an optional extra. It's a critical part of your foundation system. Where does this water come from? It can be rainwater pouring off the roof and pooling at the walls because of a lack of gutters. It can be poor grading, where the land slopes towards the house instead of away from it, directing every downpour straight to your foundation. Or it could be a high water table that constantly keeps the soil saturated. A good design must include robust drainage solutions. This means installing gutters and downspouts to carry roof water far away from the building, grading the site correctly, and in some cases, installing subsurface drainage like French drains to intercept and redirect groundwater. Remember, water around a building weakens the foundation. The foundation's strength doesn't just come from its shape and size. It comes from the steel reinforcement, or rebar, inside the concrete. Concrete is strong in compression but weak in tension. Steel is strong in tension. Together they form a powerful composite material. But this only works if the reinforcement is done correctly. A common and incredibly dangerous practice is using undersized reinforcement. A contractor might use 10 mm rebar when the engineer's design specified 16 mm to save money. This drastically weakens the foundation, making it unable to resist the forces that cause cracking and failure. Another critical detail is concrete cover, the amount of concrete between the rebar and the outer surface. If there isn't enough cover, moisture can penetrate the concrete and reach the steel, causing it to rust. Rusting steel expands with enormous force, cracking the concrete from within and destroying the foundation's integrity. Using undersized reinforcement is dangerous. Finally, even the best design and materials can be ruined by poor workmanship on site. The construction phase is where the plan becomes reality, and quality control is paramount. One of the most overlooked steps is soil compaction. When foundation trenches are backfilled, the soil must be returned in thin layers, with each layer being mechanically compacted to the right density. Simply dumping the soil back in leaves it loose and prone to settling later, which can leave parts of your foundation slab unsupported. Another critical process is the curing of concrete. Fresh concrete needs to be kept moist for a period of time after pouring to achieve its full design strength. If it dries out too quickly, it will be weak and brittle. Proper supervision by a qualified engineer is essential to ensure that every step, from mixing the concrete to compacting the soil, is done exactly as specified. At this point, you might be thinking that all these tests, engineering fees, and high-quality materials sound expensive. And yes, doing it right does require an upfront investment. A proper soil test and engineering design might add a small percentage to your initial budget. But you must see it as an investment, not a cost. Spending a few £100,000 now on a soil test and proper foundation design can save you tens of millions in the future. The cost of underpinning a failed foundation, repairing major structural cracks, or in the worst-case scenario, demolishing and rebuilding, is astronomical. It's the classic definition of being penny-wise and pound-foolish. Investing in a solid foundation is the single most important financial decision you will make in your building project. So let's recap the keys to a building that lasts. First, always carry out a professional soil test before you build. Never assume the ground is good enough. Second, hire a qualified structural engineer to design the correct foundation based on the soil test results. And third, ensure high-quality materials and supervision during construction. Your home is more than just a building. It's your sanctuary, your legacy, and one of the biggest investments you'll ever make. A good foundation is the life of the building. Protect it. If you found this information helpful and want to learn more about building smart in Nigeria, please subscribe to my YouTube channel and like this video. Your support helps us create more content to empower homeowners just like you.